Right, so you've got an assignment deadline coming up, 26th, I think, from memory. And what are you going to get the points for? Well, one of the things you're going to get the points for, obviously, is the PCB. Without that, you don't really have much at all. So it might be worth slightly refocusing your attention on the design of that printed circuit board, because that's the one that's going to get you the most marks. You know the old thing, when you go into an exam, you don't concentrate on one question, you concentrate on the ones you know the answer to, you get the money in the bank, and then you go back to the things that annoyed you. And that's where I think you are with these circuits. You're nearly there, so close there that you don't want to let them go. But this one here is a high priority. That's where you get the marks for. I've built one on the end here. Like I say, it got annihilated in my sandwich box, but I'll show you that working hopefully in a second, and if worse comes to worse, you can just duplicate it wire for wire and you can get that working. Okay, so printed circuit board, high priority. Start writing that report now. Start writing what your findings are, start writing about the problems that you encountered, and be critical of the circuit. Why is it a good circuit? Why is it a bad circuit? What is it designed to do, and so on. Now, it's also plain to me from last week that many of you don't get exactly what's going on here. I think you get the charge bit, so you can see that, and I've asked you to put it onto the oscilloscope or put it on the multimeter so that you can see that voltage starts to grow when you illuminate the solar panel, right? And it starts to grow. Why doesn't it grow in a straight line? Why doesn't it grow in a straight line? So what, I've got a solar panel, remember? Very simple circuit here. I've got a solar panel and it goes into a capacitor. Why doesn't it just charge like that in a straight line? Well, it's calculus, isn't it? I mean, it's, capacitors have an exponential charging curve to them. The other thing is actually, with the solar panel, there's this kind of concept of a time constant, and I said to you that to get from here to here, so if this is time along this axis, this point here is about 5, what we call tau, but it's actually 5 times whatever the resistance is inside the solar panel, which changes according to the amount of light it gets, and the capacitance. Now you don't need to know those, but once you've seen the charge curve, you can sort of guess what that secret hidden resistor is inside the solar panel. You can guess it from that time constant there. Now the other thing which is causing some consternation is that people are building circuits and they're expecting them to do, so you've got a charge cycle followed by a discharge cycle, which is going to look something like this. This is probably because of the diode biasing. You've got those 2 diodes. This is probably going to switch at somewhere about 3 volts. And many of you have put an LED on the load and expect the LED to be able to discharge the capacitor. The solar panel is powerful enough to run that LED constantly. And you remember the demo I did last week? I just took the solar panel, connected it to an LED, and it lit the LED permanently. That's what your circuit's doing. So it charges, the LED comes on, but it can't discharge it. So one of the fundamental things that you need in this circuit is you need the load. You need the load to be bigger than the charging rate from the solar panel onto the capacitor. This provides it. This is a big load, very low resistance, and it'll just whoomp, all that power will flow into there, and the motor will run momentarily. And what happens after you've done that? Well, that's what the circuit on the board is doing. So it's a bit like a mouse trap or something. We're going up till we get to that 3 volts, and then we flick a switch, or the mouse trap slams shut. All of that current from the capacitor is going to flow through the motor, through the transistor, down to ground, and the motor's going to spin. The capacitor is going to completely discharge, give or take a few tenths of a volt, something like that. It's going to completely discharge. Once it's done that, you go back onto this cycle again. But this part here must have a load big enough to be able to drag that capacitor down, because otherwise it'll just stay in the on position. It's like being mega rich. You've got a bank account. If you don't spend too much money, your bank account just stays fully charged. I know that seems a difficult analogy, but my bank account, or my imaginary bank account, I can't put more than 5 volts in it, or £5, or £5 million, whatever you want. But there's a ceiling. So once I get to 5, I put another one in. I haven't got 6, I've still got 5, and that's what this is like. So you can't go higher than the source itself. The maximum you can get is what this is, open circuit. Beyond that, you're just throwing money away. You might as well open another bank account, which is why I said make sure and all the rest of it. Okay, so charge cycle, discharge cycle, you can do that without the circuit actually working. Now, I'm not trying to persuade you not to get circuits working, but what I am saying is when I mark the report, if you write it in the right way, I wouldn't know, would I? Because you can simulate the charge cycle, you can simulate the discharge cycle, that's all there is. And after that, it's just the storyline that follows. Okay? So, carry on playing with those, but keep in context that you should be making that PCB. And you're quite fast at those, so I would just have a little holiday halfway through the lesson, maybe, where you just give that PCB half an hour to an hour to refresh your skills on that. Anyone have any questions about this? So if you give me 5 minutes, I'll get that working. Then you can come and play and you can get some idea what it does. And if you want, you can wire it up the scopes and all the rest of it, and you can use that as an example for your report. I don't mind. We're all in this together. Yeah? Okay. Press on and give me 5 minutes to get this going.